How do I know what the right water pressure is for my business and application and what you're doing? I think that's really what we're here to help, because there is no magic solution. We do build a variety of different pump styles, pump pressures, pump horsepowers to really dictate that for each customer what the right fit might actually be for your budget, your application, your production needs to it. But it goes to the core is that the pump is really just that, the heart of a water jet system. So it's what's creating that high pressure water, creating that velocity of the stream is really done right at the pump technology. A couple of the different pump models that you might see, and kind of just showcasing that, what you often hear in the water jet industry, in the water jet world, there's kind of two distinct ways to create that high pressure water. There's what's called direct drive or rotary style of a pump, and then there's what's called an intensifier style pump. Both will produce high pressure water. Both are great for the water jet world. It's just a matter, again, depending on each customer's needs and applications, would kind of dictate where you might fall within there. And then on the left, you see a little graph there showcasing some of the different pressures that are available. And those pressures are going to really range from about 55,000 PSI up to, on the high end, would be 94,000 PSI in the water jet world. And as we kind of jump to just showcasing a little bit of a spectrum of our entire line of different pumps that are available. And these can be equipped with multiple different machines and platforms, but you have what will range from our Hyplex Prime, which is on that 55,000 to 60,000 PSI pump. Then you have kind of the industry standard, what's been around for a long time, which is called a 60K intensifier pump. And then the next evolution to that was what's called HyperJet technology. This delivers up to 94,000 PSI of pressure at the cutting head using that HyperJet technology. How these pumps actually work and create that high pressure water.
Direct drive and intensifier, two very different mechanical systems that will produce high pressure water. We want to get into kind of the details of that. Let's kind of start with the direct drive. It's a rotary style pump. It uses a crankshaft to push 3 pistons through 3 cylinders. It makes up about 20% of the total global market share of water jet users. So the direct drive technology. We originally invented it because it actually outputs a lot of volume of water per horsepower of motor, and it's really good for surface preparation, paint removal, mining, industrial cleaning. We use that today a lot in those applications. So let's look at the details of it. Here's a good visual from a top-down view of this direct drive, also known as a triplex because there's the 3 cylinders. So let's let this video play.
Yeah, so a pretty cool rendering for you guys to kind of see what the kind of a cutaway of what this really looks like internally at the pump.
You'll see that cam rotating. Now this is usually 800 to 1500 RPMs, kind of depending on different variables, but that's pushing high pressure water out, and then on the backstroke, it's pulling low pressure water in. There's the check valve there. It's kind of close up view of that. Really cool pump. This is a pressure control valve system that'll allow any water that's not going to the cutting head to go.
Yeah, and again, where that name comes from, it's a directly coupled electric motor to the cam or the crankshaft on there. So you get that very energy efficient design of a machine.
So the benefits of a direct drive. They're extremely electrically efficient. I alluded to that earlier, where they output a lot of volume of water for the horsepower of the motor itself. Compact in size, so if your size constraint is an issue, that's a benefit. Lower capital investment for sure versus the intensifier, which we're going to look at next. And then we make our direct drive with no additional cooling water needed. That's all part of a closed loop unit inside the Hyplex itself.
This Hyplex Prime is what we call our direct drive. Typically well suited for our machines, which would be like our Mach 100 and 200 systems. Very cost effective, great technology. Again, kind of an ideal fit for those type of machines.
Now shift gears over to the intensifier style pump. This is the most kind of common technology that's been around for a long, long time, and it's an intensification principle. So you're going to see a hydraulic system instead of a rotary system. So let's take a look at it.
Yeah. And this does the same thing, this little kind of snapshot video of that pump framework. And this will show that the top end assembly, which is the what we call the intensifier unit. So below that framework, though, is where the hydraulic motor will sit. You'll be able to see that cutaway of that intensifier unit, kind of that yellow area on that. That's representing where the hydraulic oil would be. Inside of there, that large biscuit is attached to it 2 ceramic plungers. that are just simply stroking back and forth across there. On our 60K pump, there would be a 20-to-1 surface ratio difference between that inside biscuit to the outside plungers. As those are stroking back and forth here, that's what allowing us to create that 60,000 PSI water right out to the cutting head. With the HyperJet technology, works fundamentally the same way with it. That ratio does change to a higher ratio, so we get a higher pressure of water produced by the pump technology. And then as that water then travels out through the end of those check valves, it'll then go out to what's called an attenuator, which is a pressure collection device. And that will deliver that high pressure water right to the cutting head at a amount and consistent speed to it.
So two totally different mechanical structures that both produce 60,000 to 94,000 pounds of water pressure.
Yeah. One thing to kind of point out, I know on the videos they're kind of hard to see, with the intensifier, that is going to be about 60 to 70 strokes per minute, whereas with the direct drive style design of a pump, that's going to range from about 1,000 to 1,200 RPM. So there is a fairly significant difference in the stroke rate of our two different pumps.
So in summary, the intensifier has its own benefits. You know, the maintenance intervals are oftentimes longer in between seal changes on the intensifier than the direct drive. It's better suited to applications with a lot of on-off cycles. It's faster, a little simpler to rebuild those seals in there. There's less moving parts, fewer failures and downtime. And then it's not limited to the 60K pressure point. It'll go to 94K, the intensifier will.
Yeah.
So each one has its place.
About which pump is better if they both do the same thing. And a really good question there. It's not necessarily a white or black, because there's good pumps for each individual application and customer. And again, it depends on your cutting need in terms of how much you're going to run that machine, but also budgets do come into play as well as you're trying to discern what might be the best fit for your specific shop. The screen here is that HyperJet. That's a picture of what that framework looks like. That is a fully mobile unit, so that's mounted on wheels. And again, this is typically well paired or well suited for our Mach 300, 500, even like our Mach 700 machines.
So now let's talk about the actual effects of pressure. So I know this is a big question because the pump is the heart of the whole unit, but we started with direct drive and intensifiers, looked at the mechanics of it. Now specifically the pressure. This is kind of the industry defined pressure levels. We focus on 60,000 PSI plus in the cutting environment of the water jet world. So what does HyperPressure do? And frankly, the same thing is true when you go from 40,000 to 60,000 as it is from when you go from 60,000 to 90,000 PSI. Higher pressure produces more productivity. So it's faster cutting while using less abrasive particles in the cutting stream, which leads to a lower cost per part. Those are really the benefits, the physics of higher pressure. As we raise the pressure, the jet becomes more coherent and more efficient, and lower cost per part can be achieved. That's the benefit of that higher pressure.
Cool video that we had taken at our facility here of running that same part with an identical setup. So in terms of edge quality, same thickness, same geometry of the part, and just simply running at a different pressure. So we ran one at the 60, kind of industry standard of 60K, and then the other at our 94,000 or 90K pressure in terms of cycle time improvements with the higher pressure.
And keep in mind, this is irrelevant of what pump created that pressure. It's just comparing 60K versus 90K pressure. It's the effective pressure on cut speed. And then don't forget, the 90K system that won the race there used a lot less abrasive and it cut it faster. So there's a multitude of benefits to cutting at higher pressure.
As simple as this kind of geometry is here that we're cutting for this part, I think it was a little less than half a pound with our 94K pump, whereas at 60K, it was closer to about 3/4 of a pound. And again, depending on how much you're going to cut with the water jet, but if you're able to reduce your abrasive by that 20 to 30% reduction to it, that can represent a fairly significant savings in terms of your overall operational cost of the water jet, and then how many parts it can be produced in an hour at your shop.